Okay, so now we have a practice problem. We're going to determine the Vmax and the Km, but the main purpose of this problem is to determine the inhibition type, and we also have the introduction of an inhibitor. So this is our chart. We have the concentration of the substrate, and what we need to do is find the inverse values of that. We have V initial, and what we need to do is get the inverse values of that. And we also have a V initial of the inhibitor, and we need to get the values of that also. So this is our data, and what we're going to do is pretty much send that over to Excel, and here it is. We want to highlight all of that, select for a scatter plot, and first click on one of the dots, right click, add a trend line, and you want to make sure it's linear, and you also want to make sure to display an equation on the chart. You're going to do the same thing for the other dots. Make sure it's linear, display equation, and now we have the equation for both lines. You also want to make sure to add the titles, and what we're going to do is do 1 over concentration of substrate and 1 over V initial. You can also figure out the title of the chart. And so now with the equations, what we can do is if you set y equal to 0, you can get the inverse of Km, and if you get the inverse of that, you will get the true Km value. And if you set it x equal to 0, you'll get the inverse of Vmax, get the inverse of that value, and that will give you the true Vmax value. So pretty much what we did was, with the blue curve, when x is equal to 0, y is equal to 0.0208, and the Vmax is the inverse of that, and the Vmax comes out to 50 millimolars over minutes. When y is equal to 0, x is equal to 1.96, and Km is the inverse of that, and that gives us 0.51 millimolars. In the orange curve, which is the inhibitor, we have a Vmax of equal to 1 over 0.0217, which gives us the value of 46 millimolars over minutes. We have a Km value of 1.16 millimolars. And this gives us a conclusion that Vmax decreased and Km increased, and that this is a mixed inhibition.